Alright, now let's do question 1. So in this neural net, there are a couple things we want to pay attention to. So the first thing is that we have two neurons in this neural net, neuron 1 and neuron 2. The other thing to notice is that each neuron only has one input. So what's going to happen is, at each neuron, and we'll kind of take neuron 1 as an example, I'm going to do the dot product between the inputs to that neuron and that neuron's set of weights. Except since we only have one input per neuron, that dot product's just going to look like a multiplication. So to kind of write this out, for neuron 1, our input to neuron 1 is x. And we only have one weight for neuron 1 because there's only one input. So we're going to do a dot product between x and our weight for neuron 1, w1. After I do that, I'm going to apply neuron 1's activation function to see what the final value that this neuron should output should be. And we're going to call that value A1. So now I just said a bunch of things, so you might want to pause, rewind the video, and go back. But the big idea here is we take the dot product between the input to the neuron and that neuron's weight vector. We apply the activation function to that, and that will give us our final output. Notice here then that this final output will actually get passed as the input to the second neuron. And that's a really cool thing. That's what actually makes this a neural network. So just kind of answer question 1 completely. Getting a bit indecisive with my colors here. You can see that this value, this is the value before we apply the activation function at neuron 1. This is something you can call the pre-activation value. And in the problem, we refer to that as z. So what question 1 is asking is it's asking you to give z1, z2, and then a1 and a2 in terms of all the values in the network. So what that actually looks like is the pre-activation function at neuron 1 is just the multiplication. Is just the multiplication of the weight and the input. There's no 1 on the x. It's a multiplication of the weight and the input, because this is what we do in the dot product before we apply the activation function. And then, to get the final output of the neuron, we're going to apply the activation function for the neuron to this pre-activation value. And this is pretty much what we did up here in this corner. That's what all this madness is. Now the cool thing is, now we have to get z2 and a2. Well, what's z2? Neuron 2 takes as input the output from neuron 1, which is the value a1 over here, and it uses the weight 2. So we'll do the same thing. We'll do the dot product, which because we only have one input, is really just a multiplication between the input and the weight. So the big magic thing happening here is that this input to neuron 2 actually came from neuron 1. And I keep repeating this, but that's what makes this a neural net, and that's what makes it kind of cool. And just like before, to get the final output for neuron 2, we're going to take the activation function for neuron 2 and apply it to this pre-activation value, which, as we showed, is the dot product of the input to neuron 2 and that neuron's weight vector. That neuron's weight, because there's only one weight. And yeah, that's problem 1.